My dear students, in a previous video, I introduced the topic vector algebra and I gave definition for vectors, scalars, and we have seen various types of vectors and the direction cosines of a vector and direction ratios also. And we have seen that the triangle law of vector addition and the parallelogram law of vector addition and the representation of a vector again its components in the three-dimensional coordinate system. All those ideas I am going to solve some problems in this video. In the previous video also I explained the unit vector acting along the direction of a given vector. So vector algebra problems, exercise in the CBSE textbook, I think 10.2 exercise. Vector algebra problems, the unit vector acting along the direction, unit vector acting along the direction of the given vector. Direction of the given vector A is A cap. This is equal to A vector by modulus of that vector. Modulus of that vector. This is the formula for finding the unit vector acting along the direction of the given vector. Using this idea, one problem. Find the unit vector acting along the direction of a vector. Find the unit vector acting along the direction of the vector, direction of the vector A equal to I plus 2j minus 3k. So unit vector, required unit vector is A cap equal to A vector by modulus of A. That is equal to A vector is I my plus 2j minus 3k by root of 1 square plus 2 square plus 3 square, 9, 10, 14. This is equal to 1 by root 14 into I plus 2j minus 3k. This is the unit vector acting along the direction of the vector A. Or otherwise 1 by root 14i plus 2 by root 14j minus 3 by root 14k. Also we can explain. Now, one more problem in your textbook. Find a vector in the direction of A which has magnitude 8 units. That's another problem. Find the vector acting along the direction of A vector. It is 5i. The problem is find the vector acting along the direction of the vector A equal to 5i minus j plus 2k, which has magnitude 8 units. Find the vector acting on the direction of vector J, which has magnitude 8 units. That is the problem. So you first find out the unit vector direction of A. Is A cap equal to A vector by mod A vector, and A vector is given A vector is 5i minus j plus 2k vector by modulus of a vector. The first you have to find out the unit vector and then multiply by 8, you will get 8 units of the given vector. Magnitude of 8 units you want. First finding the unit vector, after that you have to multiply with the 8 units, or if you multiply by 8, you will get the 8 units of the magnitude vector. So this is equal to 5 square plus minus 1 the whole square is 1 square plus 2 square. So that is 5i minus j plus 2k vector by 25, 26. 5 square 25 plus 1 26 plus 4 30. So this is a cap. We want a unit vector of magnitude, we want a vector acting in the direction of this vector having magnitude 8 units. Therefore, we want 8 a cap. Magnitude of 8 units. Required vector is magnitude of 8 units. See, 1 unit is a cap, 8 units is a cap equal to 8 into 5i minus j plus 2k by root 30. This is the answer. Or otherwise, you multiply 8 inside within the bracket, 8 by are 40 by root 3i, 40 by root 30i minus 8 1 is 8 by root 30 into j vector plus 8 2s are 16 by root 30 into k vector. So this is a vector, required vector acting in the direction of a vector having magnitude 8 units. That's all about the problem. Okay. Next, we will see one problem. Another problem. If a vector is given, what is another vector in the direction of the same vector, or those two vectors are collinear vectors. If two vectors acting in the same direction, acting in the same line, that is called collinear vectors. See, this is a vector, you mean. In the same direction, if you consider, that is 3a vector. Okay? See, similarly in the opposite direction, a vector, this is minus 3 times of a vector. If you change the direction, it is given by minus 3 times. That means the negative symbol indicates the reverse direction of the vector. Anyhow, these two vectors are collinear. If two vectors are collinear, one vector is scalar time of other vector. That is, see the problem. Show that the vectors, second one, so if the vector A is equal to 3 times of A vector, or A vector equal to minus 3 times of A vector, if it is a scalar multiple of either positive scalar or negative scalar, if it is the case, if A vector is 3 times of A vector, or A vector is minus 3 times of A vector, or A vector is half time of A vector, like that. This is half of A also you can consider. A vector is equal to half of A vector, whether it is positive or negative. whatever it may be, if a vector is another vector expressed in a scalar multiple, then those two vectors are collinear vectors. In this case, a vector and 3a vector, and 3a vector or minus 3a vector are collinear. Collinear means acting on the same line. This is a condition for collinearity of two vectors. So, in a problem, they are given you two vectors and they ask you to find out whether they are collinear or not. In the exercise, they have given you two vectors and they want you to check whether the two vectors are collinear. You consider this problem. Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j and minus 8k vector are collinear. They ask you to find out whether these vectors are collinear. For that, a vector, given vector considered by a vector is 2i minus 3j plus 4k. And also the given vector, they ask you to find out whether the two vectors are collinear. So another vector, given vector is minus 4i plus 6j minus 8k. You consider if you take minus 2 as a common term in all the three components, 2i minus 2, if you take this is 3j minus 3j, so minus, if you take plus 4k, if you weight divided by 2, 4k, this is nothing but minus 2 times of 8y minus 3j plus 4k, a vector. So this is, given vector is a vector and another vector is minus 2 times of a vector. Therefore, these two vectors are collinear because a vector, given vector is minus 2 times of the given vector. Therefore, the two vectors are, this is a and this is minus 2a. Therefore, the two vectors are collinear. So, when vector is minus 2 times of collinear vectors. Okay. Next problem, therefore these two vectors are collinear because this is minus 2 times of the vector A. Actually, we should not say that A equal to 3A, A vector and 3A vector are collinear. Similarly, A vector and minus 3A vector, A vector and half A vector are collinear. These set of vectors are collinear. We are not supposed to say they are equal. We are not supposed to say they are equal. This is not true. Suppose this is A vector is some 3 times of another vector. It may be some b, like that another vector. That case is, you cannot equate that. So you just simply say that A and 3A are collinear vectors because they are acting on the same line. This is 3 times of A, like that. Next, they are not actually equal. It's another vector. It means another defined A vector is one, 3A vector you can say by some B vector. If it is the case, they are one vector is some scalar times of other vector, then the two vectors are collinear. If A vector, definition is, if A vector and B vector are collinear, if the two vectors are collinear, it is one vector, it is another vector. If these two vectors are collinear, then A vector is equal to some lambda times of B vector. That is the definition. Some scalar time of B vector. This is the definition for the collinearity. Next problem, third one is find the direction cosines. Find the direction cosines of the vector I plus 2j plus 3k. Find the direction cosines of this vector. Direction cosine means DC is simply the DC is of I plus 2j plus 3k. You can consider the coefficient of ijk by xy z. This is xi, this is equal to xi plus yj plus zk. You consider this vector by R vector. This is of, you consider this vector by R vector. R equal to xi plus yj plus zk. By our definition, the DCs are, the action cosines are x by mod of R, that is formula, comma, y by modulus of R, comma, z by modulus of R. This is our formula, you know, for DCs. This is R is I plus yj plus 3k. What is mod of R? It is equal to root of 1 square I coefficient, j coefficient 2 square, plus k coefficient is 3 square. Therefore, this is equal to 9, 10, 14. Okay, so direction cosines means, direction cosines are x is 1 by root 14, comma 2 by root 14, comma 3 by root 14. These are the direction cosines of the vector given vector I plus 2j plus 3k. Okay, and next, if the two vectors are equal in magnitude, if the two vectors are equal in magnitude, then we cannot say that they are in the same vector. Magnitude may be equal, but the vectors should not be equal. That is an idea. You just I give this example, you listen. Consider the two vectors. A vector is I plus 2j. B vector is 2i plus j. See, modulus of A vector is root of 1 square plus 2 square, that is equal to root 5. Similarly, modulus of B vector is root of 2 square plus 1 square, coefficient of ij is root 5. So, their modulus are equal. Mod of A vector is equal to modulus of B vector. It is enough. It need not be the two vectors are equal. If the modulus is equal, but the vectors not exactly equal. If the two vectors equal means their components, I component and j components exactly equal. That is, A vector is I plus 2j, B vector is also I plus 2j. Then only the two vectors are equal. But in this case, the two vectors are having same magnitude. They are having same magnitude. They are having same magnitude, but they are not equal vectors. But they are not equal vectors. Equal vectors means the component wise they should be equal. I here also I. Here 2 here also 2. That's all about the idea I want to insist. Then we will continue the remaining problems in the next video. Thank you.